2 is that our gamma glide reflection sigma A, sigma B, sigma C can be written also as sigma B, sigma A, or sigma A followed by sigma B. So we have one half turn and one reflection. Or we can start with the reflection and follow it up with a half turn. In both cases we have a half turn around some point off the line. So in this case B is some point off the line A, and in that case A is some point away from the line B. So we managed to write any glide reflection as a composition of a half turn and the reflection in either order. Okay, so now we'll show that conversely, starting with composition of a half turn and reflection in either order, we will have a glide reflection. How to see that? So I'm saying that conversely, if we look at a product of any half turn with a reflection in a line of the half turn, then we will have that the result is a glide reflection. So conversely, sigma, let's say sigma P, sigma L for any point P of L is a glide reflection. Well, that's easy to show. What do we see? We see that just for illustration purposes, let's draw a line L and a point P. We see that we can always drop a perpendicular. If it's a point off the line, then we can have a perpendicular, I don't know, call it M, and something parallel to the original line, let's call it line P. And then our composition of reflection in the half turn can be written as sigma P, sigma L can be written as sigma P, sigma M in any order. Doesn't matter. Sigma L, or if we wish we can write it like that, sigma M, sigma P, sigma L. And basically we have exactly what we started with, exactly as advertised. It's a composition of two reflections in parallel lines, L and P. So we have translation in this direction, followed by a reflection in M. So that's the glide reflection that we have. And another way around this is clear as well. So in both cases, for any point P of line L, sigma P sigma L or sigma L sigma P is a glide reflection. So work this other case by yourself and show that it's going to be a glide reflection, just in a different direction, in this direction, but with the same axis. So in both cases, so the answer here is of course going to be what? Sigma M, sigma L, sigma P. And both are glide reflections with the same axis, with axis M. This perpendicular that we dropped from our point to the line is the axis of glide reflection. So it's also clear that they are different, right? Why are they different? Just as we said before, because we have the two parallel lines written in either order, in different orders, so sigma p, sigma l is not equal to sigma l, sigma p. So that's why those are different. But how are they related? What can we say about those two? They are not equal, but can you guess what's their relationship? Right, they're inverses of each other. So the same will be true for the glide reflections. If you think about it, then sigma p, sigma l is the inverse of sigma l, sigma p. Is sigma l, sigma p. We cannot say they're equal, but if we take the inverse, then they're inverses of each other. Again, check. Okay, so let's summarize what we just said in a theorem. So we said that any glide reflection can be written as a product of as a composition of a half-turn and a reflection in either order. Reflection followed by a half-turn, or half-turn followed by a reflection. And vice versa. If we have such a composition, then it must be, we have shown, it must be a glide reflection, with the axis of the perpendicular dropped from the point to the line. So the key is that the key point is if P is off line L, if our point is off the line, then we must have the composition to be a glide reflection. Okay, theorem. A glide reflection, any glide reflection can be written as a composition of a half-turn and a reflection with the center of the half-turn off the axis of the reflection in either order, as we have seen. One followed by another, or reflection followed by a half-turn, so in either order. Conversely, such a composition, just take any half-turn and a reflection, provided that the center of the half-turn is off the axis of the reflection. Such a composition, provided that center of the half-turn is off the axis of the reflection, is a glide reflection. Again, in either order, such a composition in either order, provided that the center is off the axis, is a glide reflection. Okay, so this will be very helpful for us in what we're going to do. And what we're going to do is we're going to classify all odd isometries finally in a moment. Okay. So that's our next goal, but to achieve that, we must